Hi everyone, this video is about the measures of dispersion. So measures of dispersion are variability, quantify how far the observations lie from the center. And the quick measure of dispersion is the range, which is the measure of total spread. How we find the range? It is actually the maximum value minus the minimum value, the highest value minus the smallest value. This measure is extremely sensitive to outliers and to sample size. This is our dataset. Let's find the range here. As I said, it is the quick measure. So R equals max minus mean. Therefore R here is 40, which is the maximum value, as you can see here, minus 10, which is, or minus 0 actually, I'm sorry, here it is 0, the minimum value. We got 40. So this is the range, mean, max minus mean, we get 40. And the second measure, it is the interquartile range, IQR. IQR is Q3 minus Q1. It's like you take the 50% middle data. So why it is good? It is actually good because it reduces the effect of outliers. Here we look at the spread of the middle 50% of the data. So if we have outliers, here you remove them using IQR. And how to find it here with our example. So we need first to calculate Q3. We found it 26.67. Then Q1 we found it here. So the value is Q1. So is the same way we did here. We found it 12. So IQR is 26.67 minus 12, and we got 14.76. This is the interquartile range. Now we will see the variance and standard deviation. First, variance. Variance actually is the average squared distance from the mean. Because without squaring, positive and negative differences cancel out. We get 0. So squaring ensures all deviation are positive, and also it penalizes large deviation more than small ones. So the formula for the variance, by definition, it is the sum of all distances from xc to the mean, xc minus x bar squared divided by n. Or if we have organized data, it is fe divided by the sum of times xc minus x bar squared divided by the sum of fe. And this one is for the population. We have a simplified version of this formula, which is the sum of xc squared divided by n minus x bar squared. This is the second formula. It leads to the same result actually. Now we said this is for population. In case we have the a sample, not a population, we need to adjust it by dividing by n minus 1 instead of n. So the variance for a sample is actually the sum of xc minus x bar squared divided by n minus 1. If we have frequencies, we multiply this distance by the frequency divided by the sum of frequency minus 1. Here for the second formula, you need to just multiply the variance of population by the factor of correction, which is n divided by n minus 1. For the standard deviation, it is simply the square root of the variance. So why we use this standard deviation instead of variance? Because actually standard deviation has the same unit as the data, so it is easier to interpret the result, unlike the variance. Now let's apply all this on a dataset. So let's say we have this data. To find the standard deviation, the first thing to do is actually to find the midpoint of our classes here. Once we have the midpoint, we need to find the mean. How to find the mean? X bar is, we said, is the sum of FE XE divided by FE. So FE XE. Here we use C as the midpoint. So it is 390 divided by 20. We get the mean, and then we calculate the variance through this. FE times XE minus X bar square. This total. So we apply our formula, which is this total divided by the sum of FE, which is 20, and we get this. This is the variance, 73.61. Now for the standard deviation is simply the square root of this. We get 8.57. And now another concept is CV, coefficient of variation. So as you know, standard deviation alone cannot be used to compare variability between variables with different units. So here CV, or coefficient of variation, helps us to compare variability between different datasets or scales, like two investments with different average returns, for example. So here, lower CV, or coefficient of variation, means more stable or less risky relative to its mean. So CV is the standard deviation compared to the mean. Standard deviation divided by the mean. So, and we multiply it by 100 to get a percentage. So for our case here, it is 8.57 divided by 90.5 times 100, and this gives 44% as a coefficient of variation. So that's it for the measures of dispersion. I should also know that standard deviation is the most robust one if we have symmetrical or approximately symmetrical data, because it is very sensitive to the outliers, while it is robust because it takes into account all the data, but as I said, it is very sensitive to outliers. Now, before finishing this video, I will give you two other measures. They are, we have the quartile deviation, which is the IQR divided by 2. Then we have the coefficient of quartile deviation, which is relative measures for comparison. So the CQD is IQR divided by Q3 plus Q1. So this is it, and thank you for watching. Good luck.